Hello, these are the notes for physics on Tuesday, August 25th. Today we're going to learn a little bit about the metric system and get comfortable with using the metric system with some calculations near the end. All right, so to start off with, I want to talk about the different kinds of units that we have in the metric system. The first one are our units of time, right? The metric system uses the same units of time that we do here in the United States. They use the second. Hopefully you all know what the abbreviation for a second is, and this is the symbol we'll use a lot when we're doing our calculations or our notes. We'll just simply use an S for second. Like I said before, it's the same one that we use in the English system, so we're already familiar with the units of time. The metric system also uses seconds, minutes, hours, days, weeks. Now I want to talk about distance and length units. The first one I want to talk about here is centimeters. Hopefully that's one you've heard of as well. And the abbreviation for this one is simply cm. And hopefully the approximate, if I give you kind of an idea how big this is, if you look about the diameter of your pen or a pencil, that's about a centimeter. Okay. And how do we convert it? Or how do we compare it to US units? 2.54 centimeters is 1 inch, and that's a definition. So that one's a very exact number. The next unit I would like to talk about is a meter. Right? The abbreviation for a meter, hopefully you've seen this one before as well, is just simply M. And well, how about how big is a meter? If you think about the width of a doorway, doorways are about 36 inches, or about a foot, about a yard, and a meter is just slightly bigger, about 39 odd inches. So when we think about comparing a meter, it's roughly comparison to a yard in English units. The next one I want to talk about is kilometer. Again, this is hopefully one you've heard of before. It's in the abbreviation. We just simply go with it says km. And we talk about what's an idea. How can I give you an idea how big a kilometer is? If you think about the distance from our school to Sunbury Road, that's about a kilometer's distance. Now, if we're going to convert kilometers and meters, then what we have here, we have about 1.6 kilometers will give us about 1 mile. The next unit I want to talk about are the units of mass in the metric system. First one also, hopefully you've heard of as well. This is a gram, and its abbreviation is G. So about how big is a gram? A gram is about the mass of a paperclip, so it's not very heavy at all. And if we want to talk about how do we compare that to our metric units, then about 30 grams is about 1 ounce. Right, about 30 grams is equal to 1 ounce. Our next unit of mass is the kilogram. We abbreviate that as kg for short. And about what's a mass? What's something that has a typical mass of about a kilogram? That would be a textbook. I don't know if you guys have many of those anymore, but a textbook would be about a kilogram in mass. How do we compare that metric unit to an English unit? 1 kilogram is about 2.2 pounds. Okay. Now we're going to talk about volume. Units of volume in the metric system. The first one we're going to talk about is milliliter. We abbreviate that as ml for short. And about how big is a milliliter? Well, it's the same thing as 1 cubic centimeter. That's a definition. And it's about 20 drops of water. So it's not big at all. It is not big at all. How do we compare that to some unit in the English system? 30 milliliters is about 1 fluid ounce. About 1 fluid ounce. So 30 milliliters, 1 ounce, it's really not that much. They're very small units. The other unit of volume we want to talk about in the metric system is the liter. We abbreviate that as L. And about how big is a liter? Well, this one, hope you're really comfortable with, because we see this all the time. This way, soda is sold in the store. Soda pop is sold in the stores. So a liter, about half the size of a 2-liter bottle. And I think water and some other things are often sold in liter sizes. So that should give you something you've got a pretty good handle of seeing. How do I compare liters to English units? The first one would be about 4 liters is about equal to a gallon. And saying it a different way, about 1 liter is very similar in size to 1 quart in the United States. Let's finish this up. Let's talk about our units for temperature. The first unit I want to talk about is Celsius. And we usually abbreviate that with a little circle sign here. We call that degrees. That's a symbol for degrees. And the C stands for Celsius. So if I tell you it's 10 degrees Celsius outside, you would have 10, and then you'd have that little circle for the degrees, and then the Celsius after that, the C after that. So let's get a feel for what's a Celsius. How do we use that? How do we get a feel for that? And the easiest way to see this is about 0 degrees. Oh, looks like my O got reformatted there. My degree symbol got reformatted there. About 0 degrees Celsius, that's a temperature that water freezes. And 100 degrees Celsius is the temperature water boils. Now this is nice, makes it convenient and easy for us to understand in using the metric system. 0 is when it freezes, water is when water boils. It makes it very easy to do math and some conversions. Then you look at the English system and it's just a pain in the neck. How do we do that in the English system? Well, 0 degrees Celsius is about 32 degrees Fahrenheit, right? That's where water freezes. That is 32, what we're used to in our evening news and the weather reports here. And 212 degrees Fahrenheit, that's where water boils as well. So here's our comparison. 0 degrees Celsius is the same thing as 32 degrees Fahrenheit. And 100 degrees Celsius is the same as 212 degrees Fahrenheit. So now I give you an idea what those baselines are. So let's think. If the temperature of something goes up 1 degree Celsius, is that bigger or smaller than 1 degree Fahrenheit? Well, if you look at the differences here, we only have 100 increments between 0 and 100. You only have 100 increments for the Celsius system between freezing and boiling. How many do we have in the English system? 212 minus 32, we have 180. So we need a lot more Fahrenheit units to go the same distance as Celsius units. So hopefully that tells you that Celsius units are bigger. Celsius units are bigger. So if you change 1 degree Celsius, it's a bigger change than 1 degree Fahrenheit. Okay. And the last unit I want to talk about is Kelvin. You might have heard of this one before. We did talk about it in chemistry last year. In chemistry, we realized that to do some of our calculations, we couldn't use Celsius when we were doing gas laws and things like that because Celsius goes negative. That kind of screws up our calculations. So we have to shift that scale. So Celsius was based that it's 0 was where water freezes. Real convenient for us humans here on Earth. It doesn't really have much relevance to nature. So in nature, we define 0 as when the absence of all thermal motion. If you remember that from chemistry. And that is very, very cold temperature. Now the unit this abbreviation we use for Kelvin is K. And how do we compare this? 0 degrees Kelvin, that is absolute 0. Very, very, very cold. And nothing actually in the universe ever gets that cold. There's always some little bit of energy bouncing around that keeps it slightly above absolute 0. So let's think about that in terms of English units. It's 273 degrees Kelvin, gives us 0 degrees Celsius, or gives us 32 degrees Fahrenheit. So we have that big offset. So a big number, big temperature in Kelvin, maybe still pretty doggone cold. If I told you it was 273 degree Kelvin out, you'd be sitting there, wow, that's freezing, right? It's literally the freezing temperature of water. That's pretty cold. Now, the last thing to point out here is that a degree Kelvin, if something goes up a degree Kelvin, that's the same thing as going up a degree Celsius. Their size is the same. Just that scale is shifted. 0 for Celsius is at the freezing point for water, and 0 for Kelvin is at absolute 0, the coldest temperature anything can get. And finally, one last thing, if you look in your notes page, it says, what do the stars mean? The stars. And what I'm going to tell you there, the stars are our base units. Our SI, System International, is what SI stands for. Those are our base units. And if I'm having you do any calculations, you usually are going to want to convert any numbers I give you into those base units and then do the calculation. It'll make it a lot easier. All righty. Well, to wrap up today, there's another section here that I want to talk a little bit about. And we're going to do a little bit more on the metric system. So if I come over here, if I talk about the unit for time in the metric system, we talk about t in physics. T is a point in time, or a time since t equals 0, or delta t, the amount of time, how much time has gone by, right? Delta t, our classroom. If I ask you how long a physics class is, you're gonna say, well, right now, Dr. Yates, while we're on our hybrid bell schedule, classes are about 41 minutes. So our delta t is 41 minutes, right? Just the amount of time. We use S for that, and I'm not going to we don't have any, I don't have any examples. We have seconds, I'm sorry. And then our mathematical definition of SI, the second is our base unit. Okay. Our next thing I want to talk about here again is distance and length, right? We're going to, our basic symbol here in physics, when we're talking about, these are going to be what we're putting in our calculations, right? Our mathematical symbols would be X. Right? We talk about X as a position on our coordinate system. We've done X, Y graphs in algebra, a little bit of graphing in chemistry. Delta X, that little triangle, we call that a delta. That just means a difference. So that means where's your starting point minus your ending point. All right. Or like what I was saying with delta T, what's our physics class ends at 120, I'm sorry, our physics class ends at 125, it begins at 1244. So we subtract those 2 times. Similarly, we do with delta X. Start on the left side of my desk, go to the right side of my desk. What's the distance between those 2 points? The SI unit is meters. That's our base unit, and it's our base unit. Next thing I want to talk about is mass. Right? Mass is the amount of stuff. We didn't really talk about what it was before. Mass is the amount of stuff, or the amount of stuff that something has. We didn't talk about that in chemistry way back, but that was over a year ago. What's our symbol that we use in our calculations for mass? That's going to be M. M. So I want to be careful. Our mathematical symbol, our algebraic symbol for mass is M, but M is our abbreviation for meters. So be careful just when you're writing things that you know which M you're talking about. If you're writing math, you'll know that you're talking about mass. If you're writing units, you know you're talking about distance. Okay. What's our SI unit here? We use kilograms. Kilograms, that's a good unit for us in science. And our mathematical definition, right? SI is our SI base unit is kilograms. The next one I want to talk about here is temperature. We did talk about that a little bit before. We talked about the scales. Let's talk about what is temperature. And we call that the amount of energy. The amount of energy in the small scale of motion of the molecules that make up a substance. So if you think about molecules, they're vibrating all the time. Right? And the warmer they are, the faster they vibrate, the cooler it is, the slower they vibrate, and then you hit absolute 0 and they aren't vibrating at all. All right, so that's really what temperature is talking about, the amount of energy in that vibration. What do we use as our mathematical symbol for this? We use capital T, because we're using little t for time. We're going to use capital T for temperature. So let's look at some SI units. Right, Kelvin's the one we're usually going to use if we're doing some serious calculations, but we actually measure temperature in our thermometers in Celsius. Right, so it's derived. Kelvin's the base one. Celsius is an offset from that. Right, Kelvin is our base unit. So how do we get back and forth between Celsius and Kelvin? We simply take our temperature in Kelvin and we subtract 273.15, and that'll give you your temperature in Celsius. A couple more here. Oh, and that is the end of the unit that we're going to be doing here for the end of our current unit. I've got a couple more we'll talk about in the future. I'm just going to unplug them here now so you can see. We'll soon be talking about speed, velocity, acceleration, and force will be those. So those are some upcoming ones that you'll see. Let's finally talk about some metric prefixes. Metric prefixes. So let's go over here. Whoa, I lost my metric prefixes. There it is. Let's make this a bit bigger so we can see it. So again, hopefully this is something familiar to you. We did talk about this in chemistry and physical science coming into here, but we often see this stair step kind of a thing right? Our middle is going to always be our base unit, right? Whether we're talking about meters or we're talking about grams or we're talking about liters or we're talking about, let's see, so that was mass, volume, distance. Those are the three typical ones, base units, so base kinds of things. And if we want to go up, right, deca is 10 times bigger than a meter. H is a hecto, is 100 meters. K, kilo, is 1,000. So those are our prefixes. K, kilo, means 1,000. H for hecto, meaning 100. Da for deca, meaning 10. Going the other way, they're going down by tens as well, right? This first one to the right is little d. That's deci. We're talking about 1/10. Next comes C for centi. That's 1/100th. And then finally M for milli, 1/1000th. So I want you to note my little notes here. If we're going to convert to a smaller unit, that's when we go from the left to the right. That means our decimal point has to move left to the right. So if I give you 1 meter and I ask you to tell me how many centimeters there are, we move 2 boxes. We move to the right. We're going to move our decimal point 2 places to the right. So if you just remember how to do the stair step, find the unit you're in, find the unit you're going to, how many stair steps, how many places you had to move your decimal point, and then if you went to the left in the stairs, you have to move your decimal point to the left. You go to the right in the stairs, you move your decimal point to the right. For any of you who are curious, I also put it in your folder here today, several other units here, some farther out ones, right? So we already talked about these ones here, right? Kilo, hecto, deca, deci, centi, milli, but we can go even bigger, bigger, smaller, 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 smaller. So if you're ever curious what's bigger than a kilometer, we have a megameter. That'd be 10 kilometers, right? Giga, tera, etc. So lots of funky names. Some of these you might have heard of before: micro, nano. You might have even heard of femto. There's several here I'd never heard of till I looked at this too, like atto, zepto, yocto. Oh my Lord, it gets pretty funky. The last thing I want to talk to you guys about today is going to be a worksheet. I just want you to take a look at this, practice this. We'll talk about this a little bit more tomorrow, and then we will have a quiz on Friday, and this will be some of the things that will be on our quiz, in addition to the notes that we took yesterday on scientific method. These will be the 2 topics that will be on our quiz on Friday. All right, guys, look forward to seeing you tomorrow. We will have a live class at our scheduled time, 12:44 to 1:25. Did I remember that right? 12:44 to 1:25, 10th period tomorrow. We'll go over this worksheet a little bit. We'll talk about any questions you might have, and hope things are going well. Thanks a lot. Bye-bye.